Welcome to G Fun Facts Online. For decades, some crimes have haunted communities, their files gathering dust in police archives. These are the cold cases. Mysteries with no new leads, no suspects, and families left with nothing but questions. But what if the past wasn't as buried as we thought? What if science could reach back in time and point a finger at a killer who has walked free for years? Today, we're exploring the incredible technological revolution that is thawing out a deep freeze of cold cases and delivering justice decades later. A cold case is officially defined as any criminal investigation that remains unsolved for at least a year and has no new investigative leads. But many are much, much older. The first major breakthrough in cracking these old cases came with DNA profiling in the 1980s. For the first time, a microscopic trace of blood, saliva, or skin left at a crime scene could definitively link a suspect to the crime. This led to the creation of massive government databases like CODIS, the Combined DNA Index System in the United States. If DNA from a crime scene matched a profile in the database, investigators got a direct hit. But there was a huge catch. It only worked if the perpetrator's DNA was already in the system, usually from a prior conviction. If the killer had never been arrested, the DNA sample was a dead end. This all changed with a revolutionary technique, forensic genetic genealogy, or FGG. You've probably heard of consumer DNA tests that tell you about your ancestry and connect you with distant relatives. FGG uses this exact same principle. Investigators take the unknown DNA profile from a crime scene and upload it to public genealogy databases like GEDmatch or Family Tree DNA, sites where people voluntarily share their genetic information to build family trees. The database doesn't find the killer, but it might find a third cousin or a great aunt. From there, genealogists and investigators get to work, building a massive family tree forwards and backwards from that relative. They trace descendants, looking for someone who fits the geographic and demographic profile of the potential suspect. This process famously led to the 2018 arrest of the Golden State Killer, Joseph James DeAngelo, who terrorized California in the 70s and 80s. After 40 years, it wasn't a confession or a witness that caught him, but a distant relative's DNA uploaded to a public website. And DNA technology itself has become unbelievably sensitive. We're now in the era of touch DNA, where a full profile can be extracted from just a few skin cells left on a doorknob, a piece of clothing, or a weapon. Evidence that was once considered useless is now the key to unlocking a decades-old mystery. But the revolution isn't just happening in the biology lab, it's also happening in the digital world. Think of it as digital archaeology. Evidence collected decades ago, like old floppy disks, pagers, or early model cell phones, might have been unreadable back then. But today's digital forensics experts can recover data from these ancient devices, potentially uncovering deleted emails, text messages, or location data. This new information can shatter a suspect's alibi from 20 years ago. For example, historical cell tower data can now be analyzed with much greater precision. Investigators can take a suspect's old phone records and create a detailed map of their movements around the time of a crime, proving they weren't where they claimed to be. The internet itself has become a vast archive. Investigators, sometimes aided by artificial intelligence, can sift through old web forums, archived social media pages, and the Wayback Machine to find new leads. They might find a suspect bragging about a crime under a pseudonym, or discover a previously unknown connection between a victim and a suspect. This brings us to the growing role of AI. Cold case files are enormous, often containing thousands of pages of reports, witness statements, and evidence logs. It's impossible for a human to hold all that information in their head and see every possible connection. AI-powered software can ingest all of this data and analyze it in minutes, flagging inconsistencies, identifying patterns across multiple cases, or highlighting a piece of evidence that was overlooked. It acts as a tireless, brilliant partner to human detectives, pointing them in directions they never thought to look. While DNA and digital data grab the headlines, other, more traditional forensic sciences have also made quiet but powerful leaps forward. Take, for instance, forensic palynology, the study of pollen. Pollen grains are unique to specific plants, regions, and seasons. They are also incredibly durable and can cling to clothing, hair, or vehicles for years. A specialist can analyze pollen found on a victim's body, preserved in an evidence bag for 30 years, and determine not only the precise geographical area the crime occurred in, but also the season. If that specific pollen profile matches soil from a suspect's boots, it creates a powerful link. Then there's stable isotope analysis. The chemical elements in our bodies, like oxygen, carbon, and strontium, exist in different forms called isotopes. The ratio of these isotopes varies based on the geology and water of the region where a person lives and the food they eat. By analyzing a strand of hair or a piece of bone from an unidentified victim, scientists can create a geographical timeline, revealing where that person spent the last months or years of their life. This has been instrumental in finally giving names to John and Jane Does, who have been unidentified for decades. Even classic techniques have been supercharged. Ballistic analysis once relied on a human expert looking through a microscope to compare striations on bullets. Now, high-resolution 3D imaging and automated databases can make more objective and precise matches between a bullet found at a 1990 crime scene and a gun recovered just last year. Of course, this technological arms race isn't without its challenges. Cold case units are often underfunded and understaffed. Evidence, no matter how well preserved, can degrade over time. And the use of public genetic databases raises significant ethical and privacy questions that society is still grappling with. How much of our genetic privacy are we willing to trade for public safety? Despite these hurdles, the momentum is undeniable. The convergence of forensic genealogy, advanced digital forensics, artificial intelligence, and ever-improving traditional techniques has created a golden age for solving cold cases. Hundreds of cases that were once deemed unsolvable have now been closed, bringing perpetrators to justice and, just as importantly, providing answers to families who have lived in the shadow of uncertainty for far too long. It sends a powerful message. In the pursuit of justice, there is no expiration date. Science, in its relentless march forward, is ensuring that while justice for some may be delayed, it will not be denied.